Hello everybody, nice you joined me. In this video tutorial I will give you a quick start into Unity UI Toolkit from a developer's perspective. I am Ute Tropp, a professor at the University of Applied Science Darmstadt, and I'm a web and .NET developer. So I am not a Unity expert. Don't worry, this will be not a slideshow, but hands-on and practical. I will use Git with LFS activated, so all the code I'm showing will be available in a public GitLab repository. UI Toolkit can be used within the Unity editor, so you can define some stuff for the Unity editor, or you can define your UI of your game, and that's what I'm doing. So I'm not addressing the editor stuff, but the runtime stuff. In this little playlist you will find 3 videos, the basics of this video, where I will show you how to define your theme and make some simple UI. In the next video I will show you how you can switch between 2 screens. I will use a login and a registration example. And in the last video I will show you how you may have a navigation on the left-hand side and your main content changes according whatever you select in your navigation. So why am I using UI Toolkit? It's the future UI development in Unity, and it combines the 2 things I know quite well, web development and .NET. However, most of the things I know from the .NET world are not possible now. You will find many similarities you know from the web, if you know the web, within UI Toolkit. So whenever you want to have UI with the UI Toolkit, you will need a UI document. You may define your layout and whatever controls should be visible on the UI, like buttons, in UXML, which is quite similar to XAML in .NET, but only similar. And as in the web, you have your style sheets to define the look of your screens, controls and panels. And all the interaction is written in C# code, similar to whatever you're doing in the web with JavaScript. If you're very familiar with Unity, I strongly suggest you have a look at the 2 examples provided by Unity, which is the Dragon game and a Quiz UI game. Quiz UI focuses on design patterns, and Dragon, well, it's a good game. To have a good starting point for real UI development for a game, have a look at Dragon. Before we finally dive into the code, I will have a short look at the roadmap and the versions of Unity. At the moment, the latest LTS version is 2022. The next LTS version is in development, and there are some preview versions of Unity 6 available right now. This should become the next LTS version by the end of this year, 24. So far, we only have 2D because we don't have world space. Within 2022, we do not have data binding as you might see it in some videos. But never mind, because so far, even in the new version, I haven't seen any command binding. So for now, I'm not using data binding. However, I might have a look at it in a later video. Whenever you start programming, you always have to think if you're going for feature first or function first folder structure. The examples provided by Unity choose a function first folder structure, so I am doing the same. So here we have our empty project. First, what I do is creating the folders I need. So I need a new folder where I put all the UI stuff. A folder for my UXML files. As I said, the first thing you need is a UI document. So you go into your scene and choose UI Toolkit UI Document. You will realize that I do as less as possible in the editor. This has two reasons. First, I'm a developer and not a Unity expert. And second, whatever you are doing within the Unity editor might lead to conflicts if you try to merge your work with the work of other developers. So here we have the UI document, and the first thing you need to check are the panel settings. So for example, you can say to scale with screen size and leave the rest untouched. Now we need a UXML file. So we define a new UI document now in the assets folder and not in the scene. We should give it a good name. And then we can first open it with the UI builder. The UI builder offers you the possibility to define your UI with a simple WYSIWYG editors. So you can add those controls to your UI. The first thing you always need is a canvas, a panel for all your stuff to get in. So that's the main container for all your controls. Then you can add buttons and labels. Of course, you can also define your own custom controls, and you can define the layout. The layout is a flex layout, so you have many possibilities to arrange your controls here. And you see instantly what it will look like. You can spread those elements or center them. Something like this. So far we defined what the UI should look like, but we did not connect these controls with our scene. So the next step is to take your scene and define the source asset. So now let's run our scene. And depending on your scale mode, you might not see everything, so make sure to play around with the slider to see your UI. Nothing fancy so far, no styling, just some controls. So the next thing I suggest, you open up Rider. Anywhere in your assets folder, you can choose OpenC# project. And first, you should define your main colors and fonts. So add a new file, call it main.uss, for example. And if you know web development, you will see many similarities. First, we define some variables we can easily change in one place, just in main.uss, and use those variables in other files. To make these variables for all styles available, you need this double-dot-root selector, and we define our colors, we defined font sizes, we define spacing. There are many Unity classes already defined, and if you're in trouble, try to adapt them to your needs and reset padding and margin, for example. So far we defined those variables, we did not use them, and they only sit in this main.uss. They are not available to the UI. To make them available to your UI, you need to adapt the Unity default runtime theme, simply add a style sheet and drag and drop your just defined style sheet here. In code, it simply added an import to your theme file. So you can also work in this theme file to add your USS scripts, which should be available to all UI scripts. So with USS, you can adapt your theme, and I strongly recommend to use variables for colors and other things you need to reuse. Otherwise, you copy and paste them, and later on you have to adapt them all, and someone is using 8 pixels for spacing, someone else is using for the margin 4 pixels, and that's a hassle to make it consistent. So use variables and a main.uss file to be consistent. The next thing is to talk about naming conventions. BEM is widely used as a standard in CSS, so I recommend to use BEM for your classes. You basically define the block, an element, and a modifier. For all the controls you always need, like buttons or primary buttons, you may also put them in your main.uss file. For example, I'm redefining the class Unity button, and I'm defining the control button, how it should look like. Now I'm using the variables I defined previously. To do so, I need to add var and then put a variable in it. So I define a border radius, a font size, something about transition. This applies for all buttons. Now it's time to have a look at the UXML code we had before. That is the UXML which was created for us by using the UI builder. So we have a button with text button and some other things I'm not interested in. Whenever you need something explained, you may easily copy and paste those lines of code into GitHub Copilot or any other large language model and let them explain to you. I can assign a class to each element or many classes. To have many classes applied, I simply separate them by space. So in this case, I'm going for the primary class I defined here. I have a button and I have a button dot primary. If I'm using the dot syntax, like here or like here, it says it defines something for a class with this name. So now I have a primary button, and we will have a look in a second how this affects everything. Here I have so-called inline styles, which will override everything else you defined in USS files. So let's put this stuff into a USS file. This should not be available for all other UXML files, but only for this welcome screen. So we call it welcome screen USS. And I'm reusing these parts. And define a class panel and put them in here. So far, this UXML file does not know anything about this USS file. It only knows everything we defined in main.uss because it's part of the theme. It's imported to the theme. So to make this styles available here, we need to define it with the style and the source attribute. We can address this source relatively. And now we can use this class for the panel. So we use the class primary from the main.uss button primary. It will only apply for button primary. And we use the panel class we defined here. Let's see how this affects our UI. The button changed and the rest should be the same because we just moved the inline style to the USS file. In many cases, you will wonder what happens with your UI, and that's the point where the UI Toolkit debugger will help you. So you can choose Window, UI Toolkit, Debugger, select your panel, and here we will find our example UI container with a visual element. It has the class panel, and we have a button, and applied to this button we have the Unity text element class, the Unity button class, and the primary class we assigned. You can't get rid of those classes as far as I know, but if they hinder you somehow, you can overwrite them. So this debugger might be very handy. And there are some more. You can even debug events. So have a look at those windows if you run into any troubles. There's one more thing missing. We only have the UI and how it should look. We don't have any logic or interaction. So now we have to define scripts. So we define the C# script and call it, for example, Example UI Manager. There are some more options where you can just define controller classes, which we will discuss in the next video. So for example, to have some simple interaction, we want to click on the button and the content of the label should change. So first we define our controls. And now I come to naming convention in your code and of your UXML. To be able to address your button and your label, they need to have a name. And as I said, I come from the .NET world. Here it is common to use Pascal casing for the control names. For example, I have a demo button and then I will call it demo button. Or I have a label and then I call this label demo label. So now they have a name. It's like an ID in HTML, and matching to this naming convention I name my fields demo button. It's private, so I use an underscore and start with the small letter, and I need the label. To initialize those private fields and controls, I usually define a method set visual elements. Then I fetch the UI Document object and the root element. That's comparable to window and document in the web world. And now I can define those members with something similar to document getElement by ID. So I have my demo button and I do the same for the label. So now we have this method set visual elements, which is also used by the examples provided by Unity. So it seems to be quite common, where we define our members by using this queue method, similar to document getElement by ID. Now we have to define the interaction. And for example, we want that we press on the button, the label should change. And for example, we want to change it with each press on the button. So let's define a private counter, register the event handlers. So for the button, we have a clicked action and can assign this lambda to it, where we take our label and change the text by hello world count is something, and increase the counter whenever we press it. To have access to the variables and have string interpolation, in C# you can use the dollar notation. So now we have defined our methods, but we have not called them, which is quite good to put it into the onAble method. This is called when the object becomes enabled and active, where we have all these things set up and available. The last thing we need to do is to wire up our scene UI document with this script. So as usual in Unity, you can add a component and just start typing. So we have this example UI manager. Now it's wired up. We save the scene. We can even debug it. For example, put a breakpoint in here. Start a debugger. Start the scene. The debugger stops here. We can check if the demo button is initialized correctly. Yes, we have an object. It's not null. Do the same for the label. And check the value of the counter. Move the breakpoint and continue. And if we press the button now, we have this new text, and then it changes and increases whenever we press the button. So that was some very basic stuff. Whenever you use UI Toolkit, make sure to add your UI document to the scene, adjust the panel settings as needed, add your UXML file for your UI, where all buttons and labels, etc. are defined. Within the UXML file, include your style, define the interaction in your script, and add this script to your UI document. See you next time. Bye bye.